All right, so new episode. So what do we start? Did you want to talk about the deposit? Do you want to start from the beginning or just?
No, I just wanted to quickly mention because I
Okay.
promised to take another look into the diagonal contracts. And so what we concluded is that as long as flows are forwarded one-to-one, there is no clipping issue. Or if you add several incoming streams into one, that's all okay. There may be issues when you split incoming streams. So I guess if you set a fee and if the proportions are randomly unlucky, it may actually fail. So maybe we're able to create test case where it does fail.
I mean, it may and it definitely can. And if you do some sort of fuzzing with different conditions, you'll definitely trigger that. And there is workaround in a way. It's actually visible in our test app called MFA Multiflow Tester app, I think. So there's a logic that actually understanding what's the current old deposit left for the app to use. So you can actually deterministically use as much as possible from the app credit that you have. But that does make the logic slightly a bit more complex, but it's a bit more reliable. But it's definitely reliable, 100% reliable using that. So that's the option.
Okay, thank you for that. I didn't know about that, Meow. So there's a sample contract in the one of the sample contracts, MFA Multiflow. Yeah, okay. The one thing we need, perfect, you're showing screen. The other thing, which I think we talked about briefly last week, was with Axe. So the way Axe is doing it, where essentially you clip the last 32 bits of the flow rate. Now, is this also a safe way to handle the clipping issue, where in 96 we zero the last 32 bits always? Yeah.
That also works.
Yeah. Because we think, so we're going to address this actually pretty soon. So we were thinking either zeroing the 32 bits. I haven't looked into this MFA flow, so I will have a look into it. Oh, it's even written in Foundry. Look at that.
Oh, I'll introduce a bit of the Foundry stuff, but that in our code base now already.
Oh, amazing.
So Joshua has a Foundry template. If you want to do anything Superfluid or super app, there's a template there. And inside our code base, we also have a Foundry integration for a couple of test cases just for show how to do it, but we don't extensively using it yet because there's no code coverage plugin using it. What I want to show is Multiflow Tester app. Yeah, you see my screen?
Yeah.
You see? Yeah. So in the update Multiflow, there is a specific logic regarding. Okay, so let's start from beginning. Let me make a bookmark here. Can't remember this editor, how to make a bookmark. Control-Shift -2. Okay, let's jump to, there you go. Here's the after agreement created, right? So in the context, so you can actually decode the context. It does cost a little bit of gas, of course. And in the context, you can access something called app allowance granted, right? So this does tap into a bit more detail of how protocol works. And but with this, you could actually calculate what's left in terms of how much app credit you are granted. And you can use a CFA function called maximum flow rate from deposit, right? So from the allowance, what's the maximum flow rate allowed by this amount of allowance? So basically, you can deterministically know that what's the maximum flow rate I could create without causing trouble, right? So this way you can use every bit of it. But the code obviously it's a bit more complex because it does tap into the detail of the protocol. So the other approach that you mentioned with a clipping of the flow rate definitely can work, I think. But I would still recommend write a Foundry fuzzing just for the for the fun of it. I mean, but I think if you run enough, Echidna is also a good one, but don't have an example for you yet to show. But Foundry one definitely can try it out. Yeah, clipping is okay in general as a workaround, just make the code simpler. But one caveat I would mention is that while the clipping itself is not very expensive in terms of lost precision, but if you factor the price, which is if it's in ETH or if it's a wrapped Bitcoin, then it's actually quite expensive. So what do I mean is that just to recap, clipping is clipping off the lower 32 bits, right? So basically you round to the power of 32, if I'm correct. So that's the quantile of minimum deposit you can represent in the system. All right, so for this, if you factor 1E18, well, it doesn't look like much, but let's multiply by hour, 24, 30 days. All right, that's starting to look like a lot, right? Because if it's USDC, you don't care. But if it's if it's Ethereum, it's something every month you can represent, right? If it's Bitcoin, it's even more. So this clipping does introduce some issues when you factor in the monthly value of it, right? So keep that in mind. So if you're dealing with USDC, it's not a problem. That basically means that your minimum deposit monthly is 0.01. Right.
Now I have a question. In this concrete case of diagonal, wouldn't the pragmatic solution be to just, because as far as I know, there will be only a very restricted set of super tokens used, I think stables. And if that's the case, isn't it much easier to just make sure that the super app has just a very small amount of it on its balance? Maybe one DAI, for example, would totally eliminate the whole issue.
I suggested Tony about this, but I think Tony's answer to me was, you go ahead, Tony.
Yeah. No, so the idea of seeding all super apps with some minimum amount, even if it's a small amount. So we don't really think this doesn't really scale, we think. So, I mean, anyone can create a service, which means deploying a super app from the super app factory contract. And in terms of the number of super tokens we wanted to support, it's largely the stables, USDT, USDC, DAI. However, we also want to support ETH and wrapped Bitcoin, largely because people are requesting them. Now, okay, so right, this is still a small amount, but where this becomes an issue is when we start supporting and allowing, let's say, DAOs to get streamed in their native token. So this is kind of a use case we see quite a lot popping up, is where DAOs have a certain business arrangement where they would like to get paid in their own token for streams. And in that case, if we want to support, like for every, that will be governance whitelisted, given some approvals, whatever, we still have to seed in that amount. And then we also have to, yeah, it kind of just becomes, I just really wasn't convinced it scales. Yeah.
Maybe we can do a session together and construct a test case or even with fuzzing.
Yeah, I mean, that would be
figure
tremendous.
out the least invasive mitigation.
Right. Yeah, that's one thing. I think the deposit logic will still go through some changes, especially the minimum deposit will impact the number of app credit. So when we have a minimum deposit, in order not to break any apps, the app will also get the same amount of minimum deposit as app credit. Does anyone want to clarify what is app credit? I mean, it's not really often used. Okay.
Yeah.
So all right, I don't mind to show something work in progress, to be honest. That's a lot of things here still is. So it's getting organized, but don't hold your breath, not yet. So there's a Superfluid host overview. There's a deposit. Sorry, it's not here. Excuse me. Right, okay, so it's not here yet, I'm sorry. So the app credit idea is that the design principle, what we want for the app perspective is that you don't have to have initial deposit or initial balance in order to let your app function, right? Because currently, if an app wants to create a flow, it needs buffer. And someone needs to pay for that buffer. And if the app wants to be live without having its own balance, it has to come from somewhere, right? So current design is that it is something called app credit. Will be documented in that wiki page better. So that the rule is fairly simple until the deposit come and until the clipping come and makes it more complicated. But without clipping, the concept is simple. So that if user send a flow to the app, and then the baseline case we want to support is that the app can forward the same amount flow rate to another party. So it's like one-to-one forwarding, right? So that's one of the base test case also for this multi-flow test app. So multi-flow test app is one way that tests different combinations. One-to-one forwarding, 100%. That's one use case. In that baseline use case, the app would be able to borrow from the original flow sender the same amount of buffer it uses for that stream, right? So because of that, then the app can create the same flow rate to the next participant. So that's baseline case you want to address. Then the case become more complicated that also can be tested with this multi-flow test app is to, for example, split stream into two, right? So let me show the test case, how we organized it. All right, constant flow rate test. Let's do a fold for. So there is something called a multi-flow super app scenarios, right? So hopefully this is intuitive. Excuse me. So it's one-to-one 100% forwarding. So that's a baseline use case, right? So the app doesn't need any deposit in that case, right? There are also 1-to-0 create, updates, delete. And this is kind of trivial case. The app basically eats all the flow, doesn't do anything, right? So test case is written in higher level test languages. So it's very easy to actually do your own experiment if you want. And the third case, in this case, would be 1-to-2, 50-50, meaning go to two separate participants, 50% go to one, 50 goes to another, but also 100% used up, right? So the fourth case would be 1-to-2, 50-50, but this time only 50% of incoming flow is used up. So 50% actually taken by the app. So one of the things that I think the diagonal could do is actually take a cut, kind of avoid even the issue of needing to do a small deposit. You know, I guess it's up to your fee model. I'm just presenting options. So the next one would be 1-to-2, 50-50. But this time is actually amplifying in a way, right? So you are sending 150% of initial flow. So in this case, you better to have initial balance and do a go insolvent if you don't top it up as an app. And the end result is the app will be jailed. Unfortunately, it's not tested here, but it's tested elsewhere. But this app is basically being drained. You can't set this up without the initial balance, it will fail, right? So Maybe this time to also briefly touch our new test system, which Vincent, after all the struggling, finally get a hard hat, because he has been saying it for the last, I don't know how many months, hating it. Truffle. Okay, so what you do is yarn dev contracts agreements. Right, so I do this. I'm focusing on this test case, right? So hopefully this test fails if I remove that. Otherwise, it will be alive and not good. Let's see. So now it uses hot hat. When you use yarn dev, it will use also nodemon. So if I change file, it will re-trigger the test. So it's kind of nicer TDD environment.
Vincent, did you guys ever do the hard hat, the parallel test execution?
Yeah, it doesn't really make it much faster in the CI build, but when you do it locally, it is faster. The only issue with that is if you try to focus on a test, it doesn't work. So it only works if you're running everything.
Yeah.
All right, passed. Right, so let's see that if we don't find the MFA, what's the quiz time? What's the error? Sam should know it.
Would you say the error if it doesn't pass?
If we don't find the MFA with enough balance, and you try to create a flow that is more than you have, more than you get, right? There is an app error.
What's the specific error? This is a quiz?
Yes. No,
I think doesn't the not available balance error run, or is it something different?
I was hoping you remember. I don't even remember. So let's see.
I think it's not available balance.
Yeah, I think so. Yeah. Let's see what happens. If it's green, then we're fucked. I just said F wording in life. It's okay. YouTuber says something.
You can edit it after.
Nah. Okay, revert with app rule, no critical receiver. Okay, yeah, this is most confusing name. No one understand what it is, right? No critical receiver account. That means that the receiver, the MFA, is going to critical once this flow is created, and that's not allowed. That's reverted immediately. Yeah. Yeah, here you go. Yeah, still okay. What's next? Next would be 1-to-1, 101%. It's similar to previous one, just to try that if it's small number, a small enough number to see if it's still. Oh, this one's actually without extra fun. This one is actually the negative case. Right, so this one it expects this particular error. Right, so okay, so next one would be 1-to-1, or 1-to-2, 50-50, 100%. Create partial delete. Partial delete means that one of the receiver delete the flow, right? Because the MFA sends two flow to the recipient, to different recipients, but they can delete flow anytime, right? So there's a partial delete. Previous one, all full delete, I didn't mention, right? So they all, the downstream flow are all deleted. I think triggered by probably the sender rather. Interrupt me if I'm too fast here. Okay, loopback 100%, I think it's just if you send a flow to the MFA, and MFA sends you 100% back. So that's kind of loopback. Also possible with this test app. And 1-to-2, 50-50, 100%, create full delete by receiver. So this partial delete is actually deleted by the sender using the user data. So this test case extensively use the user data. This test cases. The user data tells the app what to do. So that's one way kind of orchestrate all these test cases. So the difference between 2.7 and 2.9 is that in the 2.7, it is the sender to the MFA instructing the MFA to do a partial delete. And in case of 2.9, it is a receiver deleted stream itself. There are two receivers in this case. Welcome to 2.10 would be 1 to 2, 100% grateful delete, MFA sender flow by liquidator. Okay, this is kind of liquidation case now. Kicked in, right? So instead of delete normally by the sender or receiver, it's deleted by the liquidator. Yeah, there are more other cases. I probably start to mumble if I don't remember what's the exact cases just by reading the title.
Yeah, could I ask you a question? You mentioned potentially leaving some amount in the super app. So let's say not forwarding all of it, essentially just leaving some dust in the super app. Now the question I have in mind, how much should you leave to kind of guarantee that you will never, that essentially you will never encounter this crypto deposit issue? So how much dust is enough dust per super token?
I mean the dust itself, or you mean the flow itself? Do you still want to forward 100%?
No. So let's say, suppose we relax that condition. So we had a super app, we have one stream going in and the super token, and we want to split it into streams.
Yeah.
And then we want to essentially just keep the minimum amount in the super app to ensure that no other deposit issues happen, and then you forward the rest. So what is the minimum amount of dust required?
I think it's 4 billion Y times the number of streams, something like that.
How do you get those in the first place? Do you transfer to it, or sorry, I'm a bit slow. I didn't catch that.
I guess it's an assumption here.
Excuse me?
Yeah, I think he's trying to understand if it were pre-funded, how much it would have to be. And I think it would be a constant number based on the number of outgoing streams from a super app. But I think if it's the 2 to the power of 32, so the 4.some billion times the number of outgoing streams, that should be the safe number. Is that correct?
Yeah. Let's see. So tell me, so how many flow you are forwarding in one? 2?
So you're splitting streams into 2, essentially.
It's always 2. There's no other cases.
At least for now. In the future, there may be more, but we can assume it's 2.
Okay, let's call this particular buffer. Let's use new one buffer called clipped minimum buffer. It's not best name, but this is a number, right? So the idea is that when you create so let's say the incoming flow is let's call it flow FA, and outgoing flow F of B and F of C, right? So this one gives you app credit, some sort of app credit. Let's say the buffer amount, let's call this BA.
Since it wasn't mentioned, app credit is what's named app allowance in the code base.
Of all combination of names. If you know this project long enough, you'll get used to it. So buffer amount FA. So that's the buffer that user by default always pays without app in between, right? Then the app credit, or did you please remind me what's the other name?
App allowance.
Excuse me?
Allowance.
App deposit allowance.
App allowance. Okay.
Okay. So this one would be up to BA, but less than that, right? So that's what the app can borrow. So what you get is you need basically you need to decide FB and FC for whatever reason, right? So you get B, C. So let's see how we solve this problem. So the worst case scenario, if you just say that the FB plus FC equal to FA, somehow you decided, right? So it's exactly equal in this case. Just split the FA evenly between FB and FC flow rate. And the worst case is that I think it's BB plus BC. Worst case will be B of A and 2 times of this one. So this is worst case, I believe. Actually, -1 if I want to be precise. So to answer your question, so if you just have 2 deposits of this, 2 times of this in the app, but for each use case, for each pair though, right, that will be sufficient. That's actually a very small amount also. All right, so what I mean is for each FA, I don't know, in the system, how many expect, right? Let's say you expect 1,000 simultaneously sending that. And we're talking about the worst case, like upper boundary, right? So that means, let's call that 2 to the power of 32. And you say you need 2 times of that at least for each incoming flow, and you need 1,000 of them at least. Well, it's still a small amount in a way, right? Even if you multiply by 10,000. But let's say if you're serving ambitiously say 1 million to that app, right? Well, you're talking about less than 1 cent the token into the, right? So that's the scalability we're talking about.
Yeah, and that, but if that's an E for Bitcoin,
I think even at Bitcoin, it's actually less than a Satoshi, if I'm calculating correctly.
Talk about 1 million simultaneous stream, right? Let's talk about Bitcoin. Well, can be totally. What's the Bitcoin today? 40K? 43. And you have 1 million users.
Yeah.
Alternative is sorry, just to complete. Alternative case 2 is that you give FB plus FC less than FA a little bit. So, but that requires a little bit funny math. May make the code.
But wait a second. So it's actually no. It's actually because the outgoing streams are its number of providers plus 1, I think, because 1 is for the fee, the protocol, that's just 1, independent of incoming streams, plus the number of providers. Or does every provider get their own super app contract?
Every provider has their own super app. Well, every service.
So it's really just 2, independent of number of users.
Yeah, you always split into 2, the streams.
But then even in BTC, I think it's less than a Satoshi. It's really irrelevant.
But what if you have 1 million incoming streams? Like the
it doesn't matter, only the number of
outgoing because it's only a factor of the outgoing streams.
Yeah. I think so, right now.
Yeah, it's yeah, in this, yeah, if I'm catching correctly, it's factor of out, yeah. 2,
and if those are bundled into 2, so 1 to the provider, 1 to the one for the protocol.
Yes,
that's it. It's just
that's clean.
Yeah.
So it's 2 times 2 to the power 32 minus 1. That's the minimum amount in way.
Yeah.
Yeah.
A potential fix we can do on our side is the app credit rule, making it slightly even more complicated. It's each time you create outgoing stream, you get one extra app credit with this amount. Then you don't even need to worry about that math, right? But let's see if we'll do that. It's a changing of the rule, right?
Yeah.
So basically, for each stream you create, you can get a bit more from the user, and you don't need to worry about math. But that would take some changes in test cases. So we kind of baked in this rule at the moment. Not difficult, but to think through. Currently, we are concerned mostly about the minimum deposit, how to make it work with app credit smoothly and test it out. But I think that's an interesting thought. I think we probably should consider also. Did you follow what I mean? The new app credit rule will be each time the app create a flow, you get extra credit. So currently app credit rule is app credit rule A, right? So that's the only rule we have. You can have as much this amount from BA, but we can add a B. Is that
I think what you forgot here is it's 2 times script minimum. Okay, minimum buffer. Okay, my calculation was wrong. I didn't multiply with the time frame, so it's more than a Satoshi. Wait a second. Yeah, okay, it's considerably more. It's more like 60,000 Satoshi. Is that correct? No, 6,000 Satoshi. That's, I think. How much is that? How much is a Satoshi?
6,000 Satoshi.
Yeah.
I have no idea. Satoshi is what, 1 to the 9, 1 to the 8, right?
8. So which is 40.
$2.4.
I mean, okay, that's considerably more than a Satoshi, but probably still. And that's just if BTC is used. So in our cases.
Yeah. Okay. Thanks for this, guys. Really appreciate it.
Cool. We'll keep improving it. So
yeah. No, I think I'm still not entirely convinced playing these games of leaving a little bit stuff in the super apps the right way. I think maybe the MFA flow, like you said at the beginning, now where we actually decode the context and make sure we just pass the maximum amount. But that requires one more external call and the decoding, which I don't know if that's, it's probably worth it actually, if we can always guarantee it. And like from a future-proof point of view also, do you think when we have the minimum buffer and we have the O deposit, suppose we as a protocol did the kind of the MFA flow where we query the maximum O deposit by decoding the context. Because in my opinion, that perhaps should be the most future-proof way, because that's sort of, we're relying on the get maximum flow rate function. I believe that's what it's called. And also the context, which these always have to be correct.
Yeah, so those we're always backward compatible. So the way that contexts are built, maybe it's a good context actually to show that. So in the iSuperfluid.so, right? So there's this context thing. So this is a part of a field called app allowance used, or app allowance granted rather. So I can show you that how this is guaranteed in the test case that there will be no accident that the layout of that would change. I think it's here. Okay, before I show that, I first need to show you why it's a problem if it changes. Because of how Solidity ABI is packed, we're taking a slightly very, so this is ABI v2 encoder-decoder of Solidity feature. So before that, it's not possible to return a struct. All right. So the question is, the backward compatibility question is, if we add new fields to the context, which happens, right? Things can happen, and we can add more feature to the context. And when that happens, is your app built with this baked in, that old code, right? You have a context that doesn't have the new fields. Would that break? So that's the backward compatibility issue. The case is that it shouldn't, but there are several things need to be guaranteed. One is that the order doesn't change. If the order changed, then your code will break because your code assumes certain order, right? So, to guarantee that, it's guaranteed here that it's actually test specific. It's in the Superfluid mock, validate the context structure layout is so testing the just basically testing if that field is expected position, right? So in order to know the expected position, you multiply the pointer with a 32 to the slots number. It's like slots number 0, 1, 2, 3, 4, right? So you have to know the API decoding memory. Yeah, so basically this way kind of hard code the offset in the test code. So if you accidentally in the pull request, whichever, just accidentally moved around, then you have trouble with this test case. And you better don't delete the test case, I guess. Yeah, so that's just a comment. But I guess your question was, I'm lost in my thought stack. Is it the you're saying is it the future proof? Yeah, it's kind of future proof, but it's not. But it's also a little bit very intrusive code. You kind of tap into the dirty little secret of the protocol.
There's also something to be considered is that you cannot assume that when. No, wait a second. So you may have dust remaining in the super app if all the strings close right now. So it's no more exactly 100% forwarding. It's just approximately the same. So the sum is approximately the same, but not exactly. You adjust to the clipping.
Yeah, it's either that, either we tap into the protocol's dirty secret, or for the first stream in a super token, we get 2 times 2 to the power 32 minus 1, and we leave that as dust. And we basically we subtract in the fee we charge, or subtract, we pay the merchant, I don't know, whichever way, we subtract on one of the outgoing flow rates, and we leave that in the super app.
Or Meow, as you suggested, we really do it on the protocol side and add this amount there per string.
Yeah, I think from protocol perspective, it's all in our interest that your code doesn't get too complicated, right? So while it's kind of future proof that having the logic there, but not sure if it's best for the app auditability perspective. But in interim, I can't promise like when that feature will be in, right? So it requires a lot of testing and test case adjustment. So
Tony, will the fee immediately be non-zero initially?
We're thinking of we're thinking of having it 0. You can make some arguments. Yeah,
because if it starts with 0, as long as it's 0, you shouldn't have any issue here. So it may be that
because then it's non-zero,
then the protocol.
Right, right. Good point. Because then it's just 1-to-1 forwarding. Right, and maybe we can buy ourselves some time, keep it 0, if we fix it on the protocol layer, and then that's kind of that's a good argument for why we should keep it at 0 actually initially. Because also, I mean, perhaps a little bit from our perspective, we paid for an audit already, and we don't want to do something too crazy here. If we, because there's a little bit,
Yeah. Okay. we probably don't want to quote the so the auditor name here. Maybe let's have a chat later. I know who are they, but yeah, I have some question later. Okay, then. Well, I'll organize notes somewhere about this. Actually, I realized where it was. It was in our draw.io diagram. I haven't organized into notes, but I'll publish later. So is there anything more about this topic? Or should we conclude for now? All right. I'm going to just show a little bit how currently we are leveraging Foundry in the protocol side deployment. The development, and maybe Joshua, you can also give a quick show of the template project. Let's just show. Okay, so now the protocol development at least moved to three tests. It's a kind of hybrid. So the main local development framework is now Hardhat. Truffle is still there for the reason that the protocol scripts is still in the Truffle scripts, and the protocol deployment scripts is also the production deployment script, which is very a lot of feature in the production deployments still in the Truffle implementation. So that's why Truffle is still kept. Most likely still kept for people still in Truffle when they download the Ethereum contracts, but we are moving gradually to the Hardhat. The reason Hardhat migration is fairly simple so far is used, I think, Vincent, if you can remind me, it's a Truffle Web3 plugin, right?
Yeah, Hardhat Truffle 5.
Hardhat Truffle 5. Okay. Yeah, so that one basically made the migration fairly straightforward. Nothing need to be done. Okay, so that's two framework already. Recently also added a Foundry support. Along with that, there's a new utility under the contracts called Superfluid Framework Deployer. So this is a framework independent, test framework independent deployer. So that it deploys the entire Superfluid for testing environment, things that you would need in the constructor. And after constructing, you can use either the get framework to get the object you need, and also you can use it to deploy additional wrapper super token. Okay, so but that's not Foundry specific. What Foundry specific is sits in the test folder Foundry. So there is this Foundry Superfluid tester. So it uses the deployer and add a bunch of test helpers, including deploy the missing 1820, doing the framework deployment, get a framework, set it up, and some convenience invariance checks. Right, so these are testers. One example of how to use a tester is to see the CFA test. We have a new naming convention. We call it something Anvil. It meant a test suite written using Foundry. Someone suggested name. I think Nuno is not here, but oh, he's not here. Nuno. I still don't know how to pronounce it, but I hope I pronounce it correctly. So what you do with this tester is at in the constructor, you say, okay, how many test accounts I need? In this case, 3. And then you have all the convenience tester account available as internal variable, which is from admin 0, 4 to 0, Alice, Bob, blah, 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 right? So
Is test, which testing library does it inherit from?
it inherits the
Forge, perfect.
Forge standard one, yeah. Yes, and it also does in the setup, shared setup, it also does upgrade. So you have a bunch of upgraded token automatically. So you'll kind of boilerplate free for simple test cases, right? So in this case, there's almost no boilerplate. All you want to do is test Alice to Bob, right? So you say, okay, I want a fuzzed flow rate A, but within 32 bits, not 0 and not overflowing the int32 because I want to convert to int96. So I get a random value of A and I create a flow rate. I get a flow rate. I create a flow using CFE library. Unfortunately, it was a first obscure solidity limitation. I didn't know that I can't do this using CFA library in the tester here. So I have to always copy this line here in order to get a convenience. So it's a small thing, but that's only boilerplate. I would say that is a bit unnecessary, but just one liner. Okay, you have a flow rate. You say I want to prank as Alice. As Alice, I want to flow to Bob. I think Joshua, you wanted to remove this function, right? I don't mind. I accidentally saw that's a function. I just used it.
Yeah. It's more just like necessity. So right now, without the flow function, it's sitting at about 800 to 900 lines for the CFA library. And then if we add that, we need to add flow with and without user data, with and without context and or user data. And then we need to do all of that in the context of operators, right? So we're sitting at like, I think 8 more functions just for doing flow. Because right now flow only handles like one of those cases. So it's, it's kind of out of theme with the rest of the library.
You have some sort of preprocessor and macro, right? You don't need. Excuse me. Okay, so you prank as Alice, you send to Bob, then you test the result. You say, okay, net flow of Alice is minus flow rate, net flow of Bob is flow rate. Then in the end, unfortunately, this is still the boilerplate I can't avoid. You say check all invariants, right? So the invariants we're checking is at least 2. We can add more. It's still work in progress. There's more can be improved. But 2 of the invariants we're checking is liquidity sum. So you sum up all the real-time balance of all the counts, and they should equal to the expected total supply. And expected total supply should be updated each time you do upgrade, downgrade. That's one invariance. The other invariance is CFA specific. So the net flow sum of all the accounts should be 0. So it's a simple invariance also. Right. So after each test case, you do an invariance check. Although I just realized it's not the best test case because Joshua, do you know, or any Vincent, do you know Foundry? Can I mock the time? Can I prank the time?
Yeah.
Same transaction.
Yeah, you can use warp, VM.warp. And then
warp?
Warp.
Warp?
Yeah.
All right.
Yeah.
Cool. Let me do a live testing then. So to run the Foundry test, we do a yarn. I would do run node monk because I want the TDD environment. Forge test match contract envelope constant flow rate. Okay, so this is the one I want to monitor. So can someone type the warp to the chat so that I don't mistype it? Only 2 test case passes, but the timestamp didn't move, so the invariance kind of don't really test anything because time didn't move. VM.warp. Okay, so let's say warp one day. Does it work? warp it here maybe. Let's see. Oh, I should use plural 1 days. Yeah, here you go, 1 day. Don't respect the English.
Plural and second.
There you go. It's been weird. I mean, timestamp changed within the same transaction, right? It's I hope it actually does what it says. What I could do is I'm gonna assert this because I don't trust Foundry yet. Let's see, block.timestamp U256 A1, and I should assert block.timestamp minus A1 equal to 1 days, right? It should work.
I think warp doesn't actually increment it by 1 day. I think it sets it to the value of 1 day and it starts at 0. But I might be mistaken on that. I'll double check.
Yeah, it definitely starts at 0. So I think that
Okay.
that assertion should be true, right?
Like this.
It's the same regardless because you're going from 0 to 1 day. So then when you have 1 day now in the future, and you minus it by 0, it should be 1 day.
I don't know if the test case starts with 0, right? My start with
Okay,
system
yeah,
time.
it might start with it. But I was running tests in Foundry and it seems to start at timestamp 0 unless you set it to something else.
In any case, this should work, right?
Yeah, that should work.
Okay, let's see.
My God, too much time in JavaScript.
Yeah, I was just about to say JavaScript.
Oh, this is not JavaScript. Okay, I'm writing tests in JavaScript. There you go. Okay, now I trust Foundry a little bit more. Let's remove this. Next is same. I crank here, blah blah. Push it down. Oh. Well, this is weird test case, I would say. I mean, time changes between internal cores. It's weird. That's why I think the Echidna model is slightly better for fuzzing all the operations because Echidna, each time run an external, it also adds timestamp. Joshua, you're shaking head, but I can tell you that the Echidna can fuzzing all the operations, and it uses Foundry also, by the way. It does much more of test cases. Didn't make it work yet with the new framework, but right. So that's the overview of testing framework integration of Foundry in our system. So it's part of our CI now. So our CI runs hard hat test. Let me go over it. Run a bunch of things. So we run hard hat test, Foundry tests, header compatibility check, deployment scripts in both hard hat and truffle, and bash scripts deployment. So that's the test case we run in the CI at the moment. Okay, so Joshua, if you want to take a few minutes to just show quickly how the template works.
Sure. 1 second. Just gonna do the whole desktop. Just don't look at my mnemonics. Yes. Okay. So we have the Superfluid Foundry starter template. We can just create a repository. Just call it must super app because why not? We're gonna make it private because I'm gonna get rid of this here in a minute anyway. I'm sure you guys have done templates before, so you know it's a pretty straightforward process. Hopefully this won't take long. All right. You can clone this. Hopefully the background noise isn't too much here. I'm at the coffee shop again because, you know.
They have some interesting conversation right now.
Yeah, no, it's great, man. I actually have no idea what they're saying. I can't hear anything. I can just hear vague noise. All right, so yeah, the template comes with a very, very simple contract. It's just a super token. The test file for the super token, so we can go through here, see the test run. But the important one here is the Superfluid tester contract. And y'all actually just updated this a little bit recently. Hold on. Right. One more thing you want to do whenever whenever you're doing this is you're going to have to, at least for the time being, just do a yarn install. Just because it's the only way that we can get the Superfluid contracts at the moment. Same thing with OpenZeppelin. Well, I think you can get OpenZeppelin a little bit easier, but because Superfluid's in a mono repo, it's just easier to use yarn. We'll get that here in a second. Now, just briefly looking at this in the constructor of this Superfluid tester. Now, it's inheriting DS test now. If I don't know, I haven't looked much into the Forge standard test. I might migrate that later. I'm not really sure which one's better. But yeah, so we have a deployer here. So this deployer is what's gonna, basically kick off deployment of every single contract in the framework. They're gonna register with one another, et cetera, et cetera. We have the ERC 1820 registry. It always deploys to the same address. And because there is no real easy way to do this yet, I'm really just etching the bytecode straight onto the address. It's a monstrosity. I want to get rid of this as quickly as possible, but for now, it's the best option that I found. Then we use the Superfluid deployer. We create it, and we can actually fetch basically every address that we need in the framework from here. And then we also set up the libraries, the CFA and IDA libraries here. One more thing, I do use the prank in the VM just so we have an admin address. That way, if we want to do some, experimenting with tweaking parameters and things like that, we can always do that. And then also we have a little framework function here, just a convenience thing that'll return all the interfaces if we do end up needing them. So in here we can see biggest thing, if you want to use the libraries, like Mel said, you got to add this right here. This is our VM address. Let's see, this is the actual contract that we're going to be testing. Got a few other constants and stuff, but in the constructor, we can basically just say Superfluid tester, pass in a VM and an admin address, and we can go. And so here, these are obviously some of my own specific things that I want to set up for the test, which is just deploying a super token. And then from there, we can start running these Foundry tests. So pretty straightforward. I tried to be pretty minimal about it. I have a few things in here to help out with VS Code because it likes to yell at you for seemingly no reason. But yeah, I'm going to be making some edits here and there to this, over time. So if you guys have suggestions, feel free to send them over.
Yeah, good stuff. Let's wait for the next development frameworks that I can jump into also. I'm waiting for the next one already. Next one will be.
Next one's going to be in Go++.
What about the what is it called? Brownie? Should we integrate
the Python one? I'm not doing that, man. JavaScript is already slow. I'm not dealing with Python.
Sway.
Oh yeah.
Sway, another testing framework.
Is that also a framework, or is it just the language itself?
I think it's a language. I don't know.
Yeah. All right. So we got some time still left. I'm thinking what to talk about. Any thoughts so far? Questions?
Wait, is Sway that EVM Rust language that somebody was talking about recently?
Yeah. That's what.
I'll let you guys know.
No, they haven't moved to an EVM yet. And the guy didn't think that the linear type is useful. So I kind of lost interest. Anyway, so what else?
What do you guys want to see built using the new ACL features?
Yeah, right. ACL feature. Have we talked about this in the call? think the close-ended stuff or the delegated control of the flow is the killer use case, I guess. I mean,
yeah. Actually, funny enough, Sam, I think what would be great, having perhaps in the Sentinels an automated sort of operations. For example, automated stream closure. I think this is something you see time and time again in the Discord. This is something which, frankly, we don't really want to build if we don't have to build ourselves. And I think this is also something which, like we all know, the Sentinels need to be more profitable. We need to make sure they are profitable in the long term. And I think this could be really interesting. So an ACL way to do scheduled stream closure, and then in the future, you could also have ACLs they don't have to be ACL based, but it could just be a scheduled operation, just for within the Superfluid ecosystem. So I think this could be a really cool way for the Sentinels to expand their profitability and also provide a public good.
Yeah, I mean, for a lot of people, their interest is don't lose a deposit and someone need to serve it. And what could be built, I think we can leverage the Sentinel for extra feature for sure and for profitability reason. And Sentinel doesn't have to be just for the last minute solvency. It could be also for this kind of, proactive solvency, right? And one of the things we could do is because someone do need to pay the deposit, and if the stream creator want 100% guarantee that they never lose deposit, so somehow someone need to stake some deposit, some money in order to refund the one that lost the deposit if they don't do the job in time, right? So that's the mechanism we need to put. So yeah, it could be an interesting feature to be added. It doesn't need to extend the protocol at all. It's just part of a new auction system, maybe extension of the toga that you put up your bonds. You say that you will never get closed if you pay a fee to this toga, to basically to the current pig. That I guarantee that you don't lose your deposit because you're paying the fee, and I'm gonna extend your stream so long as you have the set up the auto upgrade contract, or you have token that I can upgrade for you, stuff like that. Right, so basically it automatically upgrade for you and top up your accounts. And if I fail to do the job, I guarantee that the deposit paid back to you from the toga bonds, right? So this kind of extension doesn't require protocol change anymore. It's actually nicely layered up. You layer the new kind of profitability on top of it.
Yeah, I like that because I mean that's something which we were going to do anyway, automatically wrap for you. But the issue with having every application build it is that you don't have the benefits of having decentralized bot network. So if you have, when you think about this auction mechanism, so you will stake some amount and then you will have the right to auto wrap for using ACL for approved users. Yeah. And then if you don't auto wrap in time, so if that user gets liquidated, then some amount, what's the how much kind of gets slashed, I guess. That's sort of
a full deposit, actually.
A full deposit amount.
But the difficult thing is who is gonna do the justice for you, right? So someone needs to say that, okay, your stream get deleted, and you have to make a case that at the time you have the balance, and there's possibility that the toga peg should upgrade, right? So you have to make your own chain case for that. So that's a design part that still need to be thinking, because how do you retroactively prove that you had the balance at the time on chain? That's the difficulty.
Yeah,
because there's
No, go on.
Because there's a legit case that you simply didn't have the money at the time, and you have to make the case. We don't want to involve off-chain proof, right? So
yeah,
that's the difficult part.
I mean, I think we're seeing this time and time again now. Like even let's say Ricochet keepers. This is just a scheduled operation which needs to happen every 20 minutes, and there's no real I actually don't see a good reason, for example, why this couldn't be just a scheduled operation as a part of a Sentinel task, instead of having each application run their own semi-centralized bot networks to do these convenience features.
Now we could invert the logic. We could say if the stream went in soil or critical or in soil event, and the keeper didn't signal on chain before that, it's not possible to avoid that, then automatically it's his fault. Because if it cannot be done, then you can just make a transaction which shows, say, see, I can't do it.
Yeah, or actually make a proof that to check the balance of the account it's not sufficient, and make an on-chain transaction that store the proof. Let's say 5 minutes is deadline. If you didn't top up your base underlying balance within that amount of time, then the Toga pig would make proof that it's not possible to do that. So, well, I made my case, and there's no way you can penalize me.
Yeah, exactly. It should be trivial to provide a contract which just stores the balance of the balance.
Although I would then ask further, then is what's our overlap if we do this kind of system? What's our overlapping with the Sentinel network versus other trying to be more general bot networks such as Gelato, right? So that's still something that I'm not so sure yet. Of course, we would like our Sentinel network more profitable. I guess that's still kind of baseline incentive for us. But I'm just wondering if we are rebuilding the wheel here or not by not leveraging other networks.
I think that part, if we are going to slash the Sentinel, there is a commitment, because if the keeper doesn't do an operation, that's it. They don't receive the money. There is no penalty.
Yeah, maybe we should generalize this 3Ps concept where the patrician part is specific to having a stake, and the rest could be open to generic keeper networks.
There's one thing that in the future, I'm not convinced that there will many people will really all be liquidated, because even protocols themselves will do convenience stream closures on the receiving end, or there will be an insurance protocol which is built on top of Superfluid, where it essentially closes streams for you. So making money through liquidations, I think, is tending towards zero. So therefore, these sort of convenience features really are going to be important.
I agree. That's more value add, right? Currently, all the liquidation are not value add, is actually a extraction of the unfortunates. I think we see the numbers. So that's not ideal. So yeah, building the convenience is making the profitability more of a actual value add. I would say that, I agree with that assessment.
Yeah, but if we don't open this feature to not just the peak, why I'm going to run as a pleb?
I think we could extend the 3PS so that each time upgrade, there is a flat fee. So there is a retainer. So you need monthly to subscribe that service. And each time the service applied, let's say you have a 10 times credit, like retainer, like monthly fee, 10 times work for you for free. But after that, we're gonna extract an extra fee, one-time fee, each time we do an upgrade for you. And the 3P can be also extended to that. So if the pig doesn't do the job and then others are free to grab and earn the fee also there.
Yeah, I like that. Yeah.
All right.
So I think, I mean, we've talked before about how, like, over time, I think more and more services and protocols are going to go do their own stream closures, right? So what if we have just a single contract? It literally it does two things. It checks to see if it can close, and then it closes if possible, right? And basically all it would do, right, is you could basically set it to say, like, if it's within 2 hours of insolvency, allow any address to close it, right? And so by having this very simple thing, everybody can approve this one contract as the operator, And then any other services that want to try and build on top of it can just hit that contract instead, right? That way I don't have to worry about, have I given closed permission to this contract, this service, that service, right? It's just everybody gives permission to the same contract, and then, any other service that wants to build on it, they can.
Yeah, that we can do. Yeah, the auto upgrader contract, the non-upgradable does just the bouncing of upgrade tokens. That contract we should just deploy.
And if you add a third function, which can take a balance snapshot in order to prove that it was really out of balance, then you could even add the staking mechanism to it.
Yeah, they just on contract get the balance and save it to a storage.
Yeah.
And you have that timestamp and you can query later. Or the Slack, the contract is going to do the slash, check that before.
Yeah, and something like the Toga could check that, and if there was no entry, slash.
Yeah.
This kind of logic is what I mean could be on like an external contract, right? Like just have one contract that its only function is foreclosing, then you could have your own, like, because each system will probably have their own systems like this, right? I'm sure somebody somewhere along the way is going to reward governance tokens for closing streams, right? But just having like a very like minimal core and then allowing people to build their own periphery around it, I think would be a big value add.
Yeah, but we can add up being with gas wars, something that the peak tried to avoid. Peak was built around that, and we are recreating the same problem. A layer
but gas
above.
wars on Polygon, it's like,
Yeah, but it's gas war. But in optimism is already problematic.
It's more a front running problem. So if I'm running a validator, I can always.
Yeah.
I mean, it does create competition to, incentivize the quickest liquidation, right? Because the thing with the PIC system right now, right, is like, if I'm not PIC, it's really like not at all profitable. It doesn't even pay for infrastructure to run a pleb, right? Like it's just not. I stopped running because I don't have any PIC positions left. So
I think with the minimum, yeah.
Sorry, go ahead.
Yeah, I just want to interject because there was something, I think you know it, but I just want to repeat that the reason was having this PIC is not because maximize profitability, but also to cover cases that are not profitable. That's probably it's a bigger reason why it was such, because the case that there are micro stream that closing them has no economic benefits to the sender. So
I think just 3 or so days ago we had 1 or 2 hours where even on an L2 closing a stream, I think would have been close to $1,000 in fees.
Yeah.
So,
Really?
yeah.
On L2 or L?
On L2.
That's a problem.
Yeah,
that's
so
the micro spike, right? A very short
Yeah.
period, but still, yeah.
I mean, it was not so micro. I think it extended over, I don't know, half an hour. So on Optimism, the peak was cost of a Uniswap. Oh, what was it? I think cost of a token transfer or Uniswap, I'm not sure, was above 200. And closing a stream consumes more gas than that. So.
Even with the minimum deposit, it doesn't really solve this problem, right? So I mean, the gas seems just.
I mean, it's to be fair, it's not really a problem to be solved because it didn't extend over the 4 hours of buffer. It was shorter than an hour, I think, but still,
It's a
it was a nice reminder what kind of things can happen, and as long as the state for L2 is not separated from the normal state on L1, the L2 is also not really.
How much was L1 then if L2 is 1,000? Like what, 5,000?
You were
L1
paying like $40,000 for a transaction. I saw pictures of that.
Yeah, it was
NFTs.
completely ridiculous amounts. The revenue of the Ethereum protocol that day was about 200 million. And it was basically all in 1 hour or so.
Yeah, and maybe in that case, it's just better the Sentinel doesn't change, don't try to liquidate anything.
At least we didn't go offline though, right?
Yeah, just stop operations.
Most Sentinel accounts probably would anyway not have enough funds on the.
I don't think any protocol can solve that kind of shock.
No.
Yeah, I mean, stuff like Chainlink just keeps running. They just pay what's to be paid. Of course,
they just need to.
But I guess most activities just stop in such a situation.
Yeah. Wow. Yeah. Wow. It's great. Did you see that Charles just went Fox News?
Trying to get a new wave of Cardano holders.
Yeah. And on the background was Bitcoin and the Ethereum was dropping, and say, "Where's ADA? Where's Cardano?" And it was on the Fox News. He also had it's on the record, but yeah, he also had a photo shoot with a ZBack person. It was funny. Anyway, that was fun discussion. I think we should do it. I mean, sounds like we have all the pieces for this feature, right? The new profitability for Sentinel.
Yeah, I think at least from the core contracts, just a way to slash the peak without being a liquidation.
All right. Maybe let's brainstorm a bit more after this call at some point. Sounds profitability. That's something we definitely wanted to improve.
Yeah.
Wanting to improve.
And it's a good service to the network.
Yeah. So that's the long answer to Sam about ACL, guys. But
you can, if you want to build it, you can code on Sentinel. It's like yeah.
Does people already start to use it?
Not really. People have asked about it. Raskritov Chinmay I think is going to use it at Hack Money for a bot, like a stream manager bot that also sends notifications and things. So that'll be probably one of the first use cases. But we have a prize out at Hack Money for best use of the feature. So cool. At our hangout session we do tomorrow, I'm gonna just present a couple of ideas that I think would be cool. So
yeah, Vincent. Is the subgraph upgraded with that new events yet?
I think on dev and on feature, but not on V1 yet.
Let's schedule.
Let me just double.
Yeah, if it's on dev, can someone help me how to use different endpoints if possible? Probably not.
I don't think you can here.
Oh no. So that means I have to go to Subgraph website. They recently copied us. No, they didn't copy. They actually used that. They hired the team that did this plugin.
Yeah,
I think. Yeah.
I think Casper told us that they just bought out their team and created the open source.
So let's see. So let's go to the dev endpoints. I wouldn't hold my breath for the Polygon yet, but let's see on dev.
So you can see how it has the flow operator updated for that.
Oh, you updated the example.
No, I don't know. I guess it just takes two first. I don't know why.
How is it possible? It's automatic added?
Yeah.
All right. Someone did it. Is that you? I'm girly.
Might be me.
Might be you. Okay. Not it. Nope.
Alrighty, I gotta go, guys. But thank you again, and I'll speak to you soon.
Bye.
Thank you for joining.
Right, Tony.
I'm gonna go and jump as well. Have a good one, guys.
I think we're wrapping up. So I'm gonna stop recording and everything. So